Next up, we have Bryan, who will be talking about Declarative Application Configuration, mixing the old with the new. Bryan Liles is a staff engineer at Heptio. When he's not writing software to get teams to move to Kubernetes, he gets to speak at conferences on topics ranging from machine learning to building the next generation of developers. Heptio was founded by two creators of the Kubernetes project to support and advance the open Kubernetes ecosystem. Heptio leverages distributed systems and open source tools to simplify and scale Kubernetes for developers and operators, unleashing IT to become an accelerator for the technology-driven enterprise. Heptio is headquartered in Seattle, and welcome, Bryan.
Oh, there we go. All right, so I have 25 minutes and 76 slides. But YAML is for computers. Who here is a YAML fan? I mean, seriously? You like the idea of YAML, but no one likes writing YAML. If you're doing Kubernetes, you would probably be familiar with some of the YAML. So let's get into this. Hello, I'm Bryan. I'm, like I said, a dev at Heptio. Really, I only like two things, cars and hip hop. Anything other than that is whatever. I'm not even sure if I even like being up here on this stage right now. But I definitely like cars and hip hop. All right, so I was asked to bring this local to DigitalOcean and answer a few questions. What was my first cloud server? Funny story, I started at DigitalOcean. I used to work here many years ago on March 31st, 2014. I don't quite remember what I was doing, but I do remember that I actually booted up my first droplet because I wanted to prove someone wrong about some assertion that I had. What did I do with it? Well, I proved that person wrong with that droplet that I actually built. And how long did it take? And here's actually the best part. It took too long. DigitalOcean has always had the we will boot droplets in less than a minute. And yes, you can boot a droplet in less than a minute. But what if you want to boot 50 droplets, 500 droplets? It takes too long to actually do it. So what I did is I actually learned Go, because I didn't know Go at the time. And I wrote something called Godot. And what Godot is the Go version of the DigitalOcean API version 2. And the reason I bring that up is because the Terraform stuff that he showed you in that talk is all built on Godot. So you don't have to be the man. You have to be the man who empowers the man is the lesson from that. So that's just wanted to put that in here. So talk. Every good talk should have a goal. I really think that if we're going to actually do these things, we should actually call our shot before we get. Because if we don't, we're just like, we'll stumble over something that will seem genius, but it was an accident. And you can't repeat those accidents. So I like to have some goals. So the first goal is this thing called GitOps. I don't know if you all have heard of this thing called GitOps, but it's fairly simple. Nick kind of alluded to it. He didn't use it by term. But really, it's basically we're going to do our infrastructure, and we're going to manage it through Git. That's basically it. And also, what I want to talk is I want to be able to manage any Kubernetes application. If you've done any Kubernetes, you've probably thrown something on there. But are you managing it? And is it easy? And also, we want to talk about making declarative applications management easy. And I put easy in quotes because it's easy for the initiated. I mean, your friend who doesn't do this, who's probably a baker or something, will not be able to do this. So not easy for them, but easy for you, the person who is interested in doing this. And then also, the most important thing is the last item, is democratize the management of applications. I'm sure almost every single one of you, if you actually work with other people, you have that one person who is your ops person who knows how to do that one thing that is critical to your business that you do not know how to do. That's the anti-pattern. And it makes for big salaries for some of us, but really we want everyone to be able to do everything in our stacks. So the first thing here is GitOps. What is it? Well, really, it's a person makes a change. They check it into a Git repository. There's some kind of approval. There's an update process that actually goes out and applies that thing, and the resource is changed. Repeat ad infinitum. That's GitOps. And the reason I'm not going to go any more into this is because Nick's slide on Git flow was actually prettier than mine. So we will skip that. But really, getting down to this, working with Kubernetes is working with YAML. And that's just something that you're going to have to get used to. That is what it is. So what does this YAML look like? Well, in this case, we have a deployment. And for who here is familiar with Kubernetes? All right, well, some of you are not, so I get to tell everybody what a deployment is. In Kubernetes, you have this concept of a pod. A pod can run multiple containers, and these are most likely Docker containers, but not necessarily Docker containers. And then there's also something in Kubernetes called a replica set. And what replica sets is saying that I want to run this pod here, or I want 4 copies of these set of pods. And what a deployment does, and this was introduced a little bit later, is allows us to basically have no downtime deploys of our software. So we can basically spin up new infrastructure before our old infrastructure has been spun down. So really, our users, our customers, have no concept of it going away. So how do we describe this? Well, this deployment, there's actually only a few interesting parts in here. The second line says that it's a deployment. Right below that, there's something called metadata, and then there's something called name that actually names it. And then everything below it is basically just describing this deployment. And then in Kubernetes, you have a concept called a service. And a service exposes pods for public consumption. So you have this cool app that's going to make you billions of dollars, but it's not going to make you a dime if no one can touch it. So a service actually makes it available for the internet. So in this case, we have this service with is called HTTP bin, and it's targeting something called HTTP bin that runs on port 8080. And we're going to expose it on HTTP on port 80. That's all this does. And then finally, we have this one more concept. This should be the only other hard part of this is an ingress. And really what this does is it says that ingresses do a few things, but in this particular case, it's basically saying that if I go to http bin.myk8s, make me hit this service. And you're going to no, that is not a new TLD. I developed this on my Mac, and because I want this to work offline. And what I did is I just configured my local DNS for anything for myk8s, basically just to go to my Kubernetes cluster. So what does this look like? And if you've never seen Kubernetes before, this is what Kubernetes looks like. I do not like typing. I am actually a horrible typer, so I alias kube kubectl to k. So whenever you see that, that's just the kube control command. And that's what it does. So what happens? What do we get here? Well, you notice we set up this URL, this http bin.myk8s, and it actually loads this app. Has anyone ever seen this app before? All right. If I can give you anything in this talk, you should go out and search this app. If you do any type of web development, really what it is it actually it's just a test app that has a whole bunch of endpoints that allows you to simulate post. There is a version that allows you to actually look at encodings and things like that. If you're actually doing anything with HTTP, it's a great application. So quiz time. Hope you all are paying attention. What namespace were those objects deployed to? Just shout it out if you know it. Huh? Default? That's correct, because it wasn't specified. So yes, it is default. What if you wanted multiple versions of the deployment service and ingress on a cluster? What would you have to do? Well, in a lot of cases, you would take that directory, you would copy it to a new directory, and this time you would probably go through and actually set a namespace for every single object, and you would apply it again. Yeah. Well, what if you wanted to deploy the service, deploy the service deployment and the ingress to another cluster? Well, what you could do is you could change your Kubernetes local config to actually point to another cluster, and you could apply it. And then finally, I believe, and so what if you had a different ingress set up in production? Let's say that you were using path-based rather than host-based. How could you actually maintain that? Oh, there is another one. There's 2 more. And then what if you wanted to apply a node affinity? And just for the uninitiated, node affinity means this. I have pods. And let's say that I just wanted to make sure that, in DigitalOcean here, I wanted to make sure that I had some instances set up, and maybe I'm getting a separate price. I don't know. I've negotiated really well. And I want to make sure that these sets of services actually only run on these things. So what you could do is say, I want to create a node affinity so that these services always run on these hosts. And maybe we want to keep them local to maybe we have something running on the bare metal, or not the bare metal, on the bare droplet that needs to actually be there. So Kubernetes provides these node affinity and node anti-affinity and pod anti-affinity. And then also inside of your YAML, a few lines in, what if I actually just wanted to change the host name? Well, I can take my editor and I can change that. So really, what I would like to talk about is declarative applications. And we talked, or actually Nick talked about infrastructure as code. And Terraform is actually, I actually agree that Terraform is pretty much the state of the art right now. And we want to talk about why is Terraform the state of the art. And it really comes down to procedural versus declarative. And let me show you an example of procedural. Oh, I thought I took all the Ansible references out. I didn't want anyone to know this was Ansible. But if you've seen Ansible, you probably know this is Ansible. So what Ansible does is it says, we have lots of YAML. We're going to throw this YAML at you, and you're going to be able to start at the top, and you're going to be able to define all these things and create all these great things. Ansible actually has interesting integrations with DigitalOcean. It's very usable. I've actually used it plenty of times. But the problem with this is that it's not declarative. Well, here's why. If you run an Ansible playbook, you run it from the top to the bottom. If you take instruction 5 and you put it in, you swap it with instruction 4, something may break, or something may not break, but you don't know. But when Terraform, if you define a resource and then you actually swap the place with another resource, it'll always work because Terraform actually takes the whole thing, resolves it to a graph, and then figures out the proper order to run things in. But speaking about Terraform, Terraform has actually providers and things for everything. Anything in the cloud you want to do, Terraform has an answer for you. But one thing we don't realize is that Terraform is a great infrastructure piece. It actually kind of falls down at the application management piece. So they give you all these tools to create services and pods and secrets and services and all the things that I was talking about earlier. But the problem is that you're not talking in your application parlance. You're actually talking in Terraform's parlance. And unfortunately, infrastructure and applications are different. So I'm going to introduce a tool that we've created at Heptio called KSonnet. And the best way to introduce a tool is just to show a demo. I don't type very fast, so I pre-typed this and sped it up a whole bunch. So what's going on here is I've generated a KSonnet app. And then what I'm doing is I'm generating a service. And then also what I'm doing is I generated a deployment. And I'm doing something weird with this ingress on the end. It's supposed to make you scratch your heads, like what this guy really said. And then finally, I'm actually deploying this thing to my cluster. Almost the same thing that we did before, but not quite the same. And just to show you that, hey, guess what? We do have this thing working, and we have this new version deployed to the cluster. Actually show you the same thing that you saw earlier. So, but what if I wanted multiple versions? Going back to that question that I raised earlier, what if I want multiple versions of my deployment, ingress, and service working in my cluster? That's not going to get us there. But KSonnet can get you there. And let me show you a little demo. Actually, let me show you a demo of how KSonnet does it. So KSonnet has this concept of environments. And it says not only you have a default environment, but what we can do is we can create a new default environment. In this case, we're going to point it to a new namespace in our cluster. But we could actually point it to a whole new cluster if we wanted to. And then what we're going to do is we're going to actually change the parameters inside of our components here. And we're going to just set a new host name. In this case, we set ks2-http-bin. And then we're going to run this. And then what's going to happen, we're going to go back to our web browser, and we're going to go to this new address. Notice one thing I have not done at all you've seen no YAML, no code, no nothing. And that's one of the things that I'm trying to do about democratizing access to Kubernetes. One of the biggest burdens or biggest challenges or biggest hurdles of getting into Kubernetes is that the YAML that people find on the internet, I bet if I go to random people's projects and look in there, I can probably tell you where that code came from, what example of what random person who created that, and we want to get past that. So how are we getting past that? Well, we defined this thing called KSonnet, and I'm going to start talking about it all the time because I really think that we are ready in Kubernetes. The ecosystem is mature enough that we are ready to actually start thinking about how we declare our applications. So what's a KSonnet app? Well, it's this blue box, and inside of this blue box, there's a few things. There's components, and there's library, and there's some vendor code that you can check in if you really want to, and there is this environments. But really what we're going to talk about here today is these two environments. In this case, we generated this thing called HTTP bin, and then we might have something for cert manager, which is really just a Kubernetes front end for Let's Encrypt. So we can actually just get HTTPS out the box. And then what we can do is define two environments. We can define prod, and we can define dev. They can have their own set of parameters. They can change host names. They can have they can change the number of replicas for pods. They can change anything they would like as long as it's already prescribed. And then what we can do is we can actually apply those two things to the cluster. And then here I actually have something explaining what's inside of my components, and we're back to our ingress, our deployment, and our service once again. So basically what I've done is we've distilled how Kubernetes is configured down to its basic parts, and then we have allowed you, the user, or whoever's running this process, to put them together in the way that makes most sense. Notice we've seen no YAML yet. So from my list of things, of grievances that I had before, what namespace? Doesn't matter. We can set that at runtime. What if I wanted multiple versions of the deployment service and ingress on a cluster? Doesn't matter. They're tied to environments, and as long as the environments are in different namespaces, it's fine. And what if we wanted to deploy the service deployment, or deploy the service and the deployment and the ingress to another cluster? Doesn't matter, because the environment actually knows. The components don't know where they're going. And then what if you had a different ingress setup in production versus development? Well, once again, it doesn't matter because you can actually change the parameters per environment. So how does this all work? I have 8 minutes to explain this to you. I hope you all are taking notes because this is going to be fun. So JSonnet is like everything interesting out there in the world, and you can quote me on this. 95% of anything interesting that you've thought of recently or saw cool was created at Google. Because whenever you create a lot of money in ads, you have a lot of time to just think about a whole bunch of other crazy things. So this is another thing. JSonnet is a data templating language. You're like, oh my God, I never heard of that before. And before I started working with KSonnet, I had neither. But it came from this thing called BCL, which was used to configure this thing called Borg. BCL, Borg Configuration Language. And Borg, the engineers who were working with Borg, not really on Borg, said, we see some great ideas, and they created this thing called Kubernetes. I can do this for like 50 products of just cool things that came out of Google. But JSonnet basically came from ideas learned at running clusters at scale at Google. So what does it look like? Oh, yeah, I forgot this. JSonnet and KSonnet rhyme. The names are just a coincidence. JSonnet is not named, or KSonnet is not named after JSonnet. If you ask anybody, they might tell you something different, but I run the project, and this is what I'm going with. So, JSonnet. We built a VS Code extension for it because I like VS Code. So I think everything that I'm going to work on should have a VS Code extension. So what does it look like? So on the left side, you'll have some JSonnet. On the right side, it'll be YAML or JSON, just depending on what the output looks like. So on the left side, we have empty objects. So you've seen JSON, empty JSON objects. Well, on the right side, it prints out an empty one. And in this case, this is where we get into some of the power of JSonnet, where we can define local variables. I think everyone here has wanted to define some kind of value in their JSON. But now with JSON, you can. So you know that you can see that the key, the object at the end that we are actually spitting out, actually has the value. So here's something very important. It's not a language that you write normal software in. It's a data templating language. So basically, the end of every single file is what you are trying to build. So that's why you're going to notice at the end of every single file that there's just either an object or an array or a string or some other kind of literal. JSON, it also has a standard library. I bet a lot of times we've wished that, well, actually, if you're using JavaScript, you do have some kind of standard library, but we can do things. We can inspect objects. We can have array operations. We actually also can do things like we can do we can do comprehensions. We can do object comprehensions. We can do folds, left and right. All these things are actually just built into this great language. And then how can you use those things? So from the previous page, I had object fields, the second one from the bottom. It just actually prints out all the, or is the second one from the top. It just prints out all the object fields. And in this case, we have an object that has a foo and a bar, and we just print out the actual keys. And then here's the final one, the final example here is that JSON, it also has functions. I can actually write functions to manipulate the data inside of my data structure and spit out a whole new data structure. Wow. So how are we doing this? Well, the environments are the magic inside of KSonnet. We're using this JSonnet language to actually manipulate and then basically rebuild all of your object configurations at runtime to spit out new things. So what are we actually working with? One thing you'll learn as the world moves to Kubernetes, there's a lot of JSON out there. This particular document is the Swagger JSON file from every Kubernetes deploy. So if you have a Kubernetes deploy, there's a Swagger file explaining how the API works because it changes per version. So one thing we did is we actually took this file and we converted it to JSON. This was lots of love, this is a month of work, but it actually generates. And you're probably saying, hey, there's some weird things there, like the double dots. The double dots behind a key means that if you were to print this thing out, it'd be hidden. So whenever we actually print the document out, it's empty. But we actually use this thing to build crazy abstractions of things you can do inside with your objects for Kubernetes. So I'm getting low on time, but I do want to show you some things here. So this first thing here is that we have a deployment. And we've actually, now this is in JSON. So our goal here is to actually generate Kubernetes objects. So we have this deployment new, and don't really worry about that. We just know that at the end, it generates what's on the right. And it generates a Kubernetes object. That's pretty neat. But what if we wanted to add a node affinity, like I was talking about before? So node affinities are interesting. But with KSonnet, I can actually define libraries. And the reason we want to define libraries is because things inside of Kubernetes are hard. If you could scroll down a little bit, you would understand that the key for creating a preferred node affinity for Kubernetes, the key is like 30 characters long. I don't know what the Kubernetes authors were thinking in this case, but they were very expressive. So what we've done is instead of having 5 to 10 to 20 lines of YAML code that you'd have to write, we've actually simplified this down to now, if you see this, it's right at the end, I'm actually adding this node affinity, the output of this node affinity, to my deployment. And why is that important? Well, that's the greatness and the power of JSON. Because it's all objects and it's an object templating language, it understands objects implicitly, kind of like JSON itself. But now what I can do is I can actually add the outputs of these two things and get this thing on the right. And just to show you that this, with a little bit more context, I'm going to add another one. And you see, like if I go back from this first one, if you go towards the middle where it says node affinity, now notice there's 2 things in the key below that, in the object below that. So that's what we're trying to do, is trying to give users great power without a lot of work. So once again, scratch something else off my list. And so here's an interesting thing here. The existing ecosystem, like I said, Kubernetes is all YAML. Well, YAML is for computers. Computers love YAML. But it's not bad. But it's not great for users, especially if you have to write stanzas that are this long printed out on a piece of paper. So what we've done is inside of Kubernetes, or inside of KSonnet, is we've just added YAML support. So now we will actually convert your YAML into something that we can handle, and now you can use it just like nothing. So I'm going to skip past this video. But now, finally, I want to talk about KSonnet in your environment. What we've done is we've created this tool, and with it comes a lot of power and a lot of ease. But what the issue that we're having is how do we actually take advantage of this in our environments? Or how do we actually use the power of environments? So this right here is an example of me applying new configuration to every single object. Now I don't have to touch every single file. So I'm adding a new project to every single thing and every single component inside of this module or inside of this environment. So, all right, so I am actually at the end of my time, but I'm going to take 10 more seconds. And I'm going to talk about this thing. If you've used Kubernetes, you've probably heard of Helm. We are actually, in our next version, we'll be supporting Helm, which means you'll be able to use these great things that you've already been using, but instead, now you can actually have power over your environments and use your existing tools. Linting, overlays, and dev, VS Code integration is always my favorite. And that's it. Lots of new stuff for you guys, but thank you for listening.